So we had some sentiment over 50,000, around 50,000 sentiments, which people have expressed over the years. These sentiments are divided into two parts or two columns. We have the sentiment itself, or the review, rather. Thereafter, we also have the sentiment. So review will be the messages or the text people typed to express their feelings. Then there is a column that shows if that feeling is positive or if the feeling so the review is this expression of the emotion, while the sentiment is there a positive sentiment, is it a positive emotion or a negative one? So today we'll be looking at what sentiment analysis is. But you know that when you want to review a movie you've watched or your experience, you have gone to a restaurant to eat, and you ask, that asks you, oh boy, how was your experience at that restaurant? You're going to type some words down. But you know that for us to work with computer, to build a model, we need to give computer numbers. Computers don't understand text as it is. So computers understand numbers. Okay? So we must look for a way of making those texts, of converting them to numbers. And that is going to be one of the jobs today. Okay, thank you. So I was saying that you understand that computers don't understand number. I mean, they don't understand text. They understand numbers. So we must look for a way or for ways of turning this number of this text to numbers. So it will be easier for our computers to learn, and we can build a model that can make some predictions afterwards. So we're going to do that. Then you remember, or you realize that when people are expressing themselves, so they tend to use some words that show their emotions. And not only that, some of these reviews are on the internet. We have restaurants on the internet where people make their review. We have movies online where people make their reviews. So when we need to use these reviews that people have made, we download them. And after downloading them, they have some characters that have a language that is associated with the internet. For instance, the internet is built with a language called HTML. HTML, that is hypertext markup language. That is the language internet understands. The internet does not understand Hausa, doesn't understand Spanish, it doesn't understand Japanese, it doesn't understand English. It understands hypertext markup language, HTML. So, but for us to use this review that we have downloaded from the internet, for instance, the Imdb dataset that we'll be using, we need to convert the numbers, the text. We need to clean it up and remove anything that has to do with internet language. We take it away. So that's what we'll be doing with cleaning messy text. Thereafter, we're going to train our system, and then we now make it fast and find some topics as we go on. Okay, so let me go this way. Okay, see, can you read this as I project? Or let me just read from here. You read movie reviews and figure out, is this person happy with the movie, or are they sad or angry about it? So that's what we want to teach our computers to do. So imagine in your computer, you have a model that can read all the Instagram comments on a post, all the reviews of a new video game, all the reviews of a restaurant, all movie reviews on the internet. Imagine you have that model. So I tell you that the computer is able to tell you what people love most. Most people love it, or most people don't like it. That is what we're going to build now. So we want to build a system that's able to tell us, oh, this video or this movie, based on this sentiment, it shows that the people that have watched it do not like it. And Amazon uses this package, uses this kind of model to know how people relate with their products. Netflix uses to know how people relate with their movies. So it is a powerful tool that are being used in many big organizations. So it's a tool that is good to know, and it's a tool that is going to enhance your skill and make you fitted for the years ahead, or for the journey ahead, and make one relevant in the era we are in. Okay. Any questions so far? Hello, Tochi. Any questions so far? Hello, can you hear me? Can you hear me? Hello? Okay. I want to be sure you're following.
Yes, I can
Okay.
hear you.
I said, do you have any questions so far?
No.
Okay. And is all the content on the screen, is it visible? What can you see on your screen? What can you see?
I see very soon all Instagram comments on a post, all reviews of a video game, all reviews of a restaurant, all movie reviews on the internet. And don't tell, yeah, that's better. Thank you.
Okay, did you see that's what we are building today? Did you see that one? Did you see that's what we are building today?
Yeah.
Oh, cool. Okay, then we move on.
What do you mean?
What is it?
What do you mean by if I saw that's what we're building today?
I said, did you see that on your screen? Did you see that's what we are building
today? No.
Okay, so you only saw all movie reviews on the internet. That's what you saw, right?
Yeah.
Okay, I see. So let me do something then. Okay. I want to be sure you see everything. So let me adjust the sharing. So can you see it now?
Yeah.
So you can see that's what we're building today. Cool. Okay, cool. Let's go on. So the challenge now, the challenge is that we have 50,000 movie reviews from IMDb. The file I just shared with you now is called the IMDb dataset, and it's a big movie dataset. So our job will be to do this basic work, to change the words or the text to numbers. So we change it to numbers such that computers can relate with the numbers. So we teach them, the computers, or to create a model, build a model that can actually make prediction, that can check. We build a model that can detect if we have positive or negative review. So that is what we will do. But we have a challenge. The challenge, as I said, computers don't understand text, they understand numbers. So the first thing I'm going to introduce you to is what I call the word banks. So in word banks, we use this as a way of overcoming the challenge of changing text to number. And what we do with word banks is that we make a collection of words and we associate them with their frequency. That means how often, how many times do they appear in a text or in a document. For instance, if I have, I am going home. So you're going to make each of those words, you're going to throw them in a bag. And you're going to say, hi, how many times does it appear? Going, how many times does it appear? Home, how many times does it appear? So you can't. And you call that word bag or bag of words. So you throw all your words in a bag and count them. Does that make sense? Does bag of words make sense?
Yeah.
Okay. So again, let me reiterate. You have the collection of your words. Imagine you have your school bag. So when you say I have a school bag, your school bag contains your books and all the stationery you use when you get to school. Traveling bag contains your clothes, your shoes, and everything you would need to use where you are going to, where you're traveling to. So those are the bags: the school bag, the traveling bag, there's grocery bag. So also we have bag of words. So in bag of words, we have collection of words that are thrown inside that bag that show us how many times they appear. Okay, see this example. I have this example here. I say the sun is shining. The sun is shining. That is a statement or a document. The sun is shining. Or I say the weather is sweet. That's another document. Each of those statements is a document. I say the weather, the sun is shining, the weather is sweet, and one is two. That is another document. That statement is another document. So we have three statements here or three documents. Do you understand? So our next job now is to change this number, to change this text and build bag of words from them. So you're going to switch on now to your Google Colab as we do some coding exercise. Let me get into the coding mode. So I'm projecting two things at the same time. I want to show you the coding. So you can see the two together, right? You can see the document and the collab script. Can you see them?
Not the collab.
Oh,
Okay, you are still seeing only the screen. I mean the document.
yes.
Yeah.
Okay, let me do something again.
So see.
How about it now? Can you see the
Yeah, we
collab?
can see the two now.
Okay, cool.
Yeah, I can see the two
So,
now.
so now on your collab script, you're gonna name it anything you like, but for you to remember to know what you're doing, you can just make it sentiment analysis, like I said. Or I already have some scripts that have the name, so let me change it to movie analysis. Okay, let me use emotional analysis. Emotional analysis. Movie. Okay, so it's up to you. You can make it anything you like, but this is what I'm going to call it for now, just for the sake of the class. So I said we're converting text to words. Sorry, yeah, I'm correct. We're converting text to words. That's our job for now because, as I said, computer does not understand text as it is. You need to relate it to words which it can work with. So again, I'll be introducing you to some concept today which we've not been using before because we are graduating now. Actually, as I said earlier on, this is a powerful tool that is used under the hood of many of these big companies' applications, especially those ones that have to do with relating with customers, reviews, making comments. So how do we know that what this guy is saying, this is what is actually feeling, the feelings? So that is a very powerful thing. So we'll be using something that we've not been using before. So we just need to learn and get on. So of course, we're going to use our popular library we'll be using now, which is NumPy, because NumPy is number Python. So we still need it to do the work. So we'll be importing NumPy as NP. Okay. Now, you remember we've been using another package or another library called sklearn. So we're still going to use that. So I'm going to say from sklearn, this sklearn is a library, as you know. We will be importing a module called feature extraction text, feature underscore extraction underscore text. Dot text. Text is a submodule. So the extract will be using from sklearn dot feature underscore extraction dot text. Then we'll be import. There is a class called CountVectorizer. CountVectorizer. So the CountVectorizer is a class inside of sklearn feature extraction.text module that helps you convert and create bag of words. Now, as you remember, when we're treating Python, we talked about how to instantiate an object from a class. So we'll be instantiating an object called count, and we'll be instantiating it on CountVectorizer, meaning that in the church way, all the anointing CountVectorizer has will be passed across to Count. So that's what this code will do. When you run this, everything CountVectorizer can do, Count will be able to do it. So we are creating a small CountVectorizer called an object from the class CountVectorizer. Okay, so this so far so good. Let me just run these 3 lines first before we continue. Okay, cool. So codes ran successfully, those 3 lines. The next thing is that I talked about document. Document as it relates to what we're doing now is every statement that is made, unique statement. All those unique statements are the document. So we need to create a document. So I'm going to call it docs. So docs is just the name. You can call it spreadsheet document, whatever. The left-hand side name, it does not really matter as such, but what you pass into it is what matters. So here we're going to use the numpy. So we say np.array. That is going to form an array of documents or array of words. So we're going to call np.array on our document. And for this document, we're going to create a list. And because we're going to create a list, you use square brackets. So you remember we use parentheses when we want to call a function. So the function we are calling here is the np.array. But inside that function, we need to pass in some argument. And the argument we are passing out is a list of those statements, those words. So now, let me do something because I need to type. So let's break it down. Now let's begin to type what I showed you the other time. So the first thing I'm going to type is the sun is shining. The sun is shining. So I want to make a list of the sun is shining. So that's the first document. Now I want to type another one. I said the weather is sweet. The weather is sweet. So that's another document. Then another document I'm going to make is, I'm going to combine them and I say the sun. Of course, you can make it anything. This is just for training purpose. So I say the sun is shining. The sun is shining. The weather is sweet. Okay. And I say again, okay, I say 1 and 1 and 1 is 2, and 1 and 1. Don't mind, just forming words. Doesn't really matter what it is. And 1 and 1 is 2. So we have these 4 statements or 4 documents that we have created. So what we want to do now is we want to create, remember, bag of words or words bag, like traveling bag, school bag, laundry bag, grocery bag. So when you have a laundry bag, for instance, you want to check how many white shirts do I have in this bag? How many pantaloons do I have in this bag? How many caps do I have in this bag? So you want to count. So what I want to do now is we want to check up what this document will be when we convert them. So what I'm going to do now is I'm going to create another variable called bag. And this object bag, I will call on it count. You remember count has been created here. We have instantiated count here. And we pass into it the CountVectorizer. So whatever CountVectorizer can do now, count can also do it because we have passed into it what is inside CountVectorizer. Okay, so we're going to do now what we call count dot. So there is a function we'll be using. So we've used this function before when we're dealing with our traditional machine learning models. We call it fit and transform. So we'll be using fit transform. So as you can see, I told us earlier on that fit trains, you use fit for training. So when you hear fit in machine learning, it means train. Then you see the word again, transform. What does transform mean? You know, when you hear transform, if you have heard before, it happens in the Bible. The Bible says, and be ye transformed by the renewing of your mind. That means your mind will be changed to something else. You hear when Christ went to the Mount of Transfiguration, and the Bible said that he was transfigured before them. So his clothes changed. So he became something else. So now I want to transform this array of documents to what we actually want. So we're calling on it count.fit_transform, and now we pass into it the docs, which we want. This is what we want to transform. We want to transform everything here to a bag of words. So let's run this code and be sure we're fine. Okay, so it ran successfully. So by
scroll up.
What did you say?
Scroll up a little bit.
Like this? Are you okay like this?
The entire code.
What did you say?
Is that all the code? Is that all the code?
That's all the code. Yes, for now. So I'll type in more, but this is all we have for now, okay?
Thank you.
Okay. Shall I continue?
Yeah.
Okay. So what we have done here now, when we call this function fit_transform, when we call it on the CountVectorizer, what we do, when you use dot operator, you join CountVectorizer and fit_transform function, you join them by dot. So what we did here was that we have constructed the vocabulary for the bag of words. And now we have transformed the following sentences, those 3-4 sentences, we've transformed them into something else. In mathematics, they call it vector. But don't worry about that. But you see now, let's print out what we have done. Let's see what we have actually transformed. So I'm going to call print function, and I'll say count dot, I said we have created a vocabulary. So that vocabulary, we have created a dictionary, actually. It's a dictionary. And in dictionary, you have a KV, the key and the value. So we want to see what is the vocabulary we have actually created. The vocabulary is what? So we said count dot vocabulary. So what do we have? You will see what's going to print out for us now. So let's see what we have done. So this is what we have done. Can you see what has happened? So there is a transformation that has happened. First of all, notice that we have the sun is shiny, weather, sweet, and 1, 2. What you would have noticed here is that all these words, for instance, there appears here 1, it appears here 2, it appears here 3. Where is it again? It appears here 4. That's there. Yeah, 1, 2, 3, 4. It appears 4 times. So because it is the same word, so when our vocabulary was created, it's just 1. So every other is just repetition. And this there becomes the key. So anytime our model needs to use those bag of words, it will not need the as it is. What it will be referencing is 6. So 6 to our computer now means the. Then look at this. Look at sun. Sun. Sun appears how many times? 1, 2. And that's just one. It's just the same thing. It's just one word. Again, you see sun is a key here, and it has a value of 4. And the same thing with others, like is. So what you will notice here is that here, if we should count the number of words here, we have 1, there is 1, sun 2, is 3, shiny 4, day 5, weather 6, is 7, sweet 8, there 9, sun 10, is 11, shining 12, there 13, weather 14, is 15, sweet 16, and 17, 1 18, and 19, 1 20, is 21, 2 22. You see all these 22 words, they are just they're just repetition of words. They are being reduced to 1, the sun, 2, is 3, shiny 4, weather 5, sweet 6, and 7. That means all these 21 words or 22 words, they're actually 7 words that we have repeated over time. Now, this is our bag of words. And if you look at the numbering, you see, and now is index 0. And if you pay close attention, you will notice that they are indexed alphabetically. And starts with A, meaning index 0. That's the first word. Let's look at the one that asked number one. Number one is what is number one? Is a key here and is attached to index 1. And if you look at it again, I follows. All other words follow on and on and on. So what we have done is we have created a bag of words. Bag of words. Okay. So that's the vocabulary that we have created. So as you have seen from here, you will see that when we executed this command, we have a vocabulary that is stored in a Python dictionary. As you know that this is a dictionary, you already know that when you have a brace, you have a braces bracket, this curly bracket is a dictionary. So you have there, the key is there, the value here is 6, son here is key, 4 is value. So the command print vocabulary created for us a Python dictionary. And what it does is that each word, each unique word there is unique, son is unique. Even though we have 22 words before, they have been reduced to 9, and they are now unique words. They are matched or they are mapped to some integer or indices, the number, the index. So the next thing we want to do now is this same document, we want to print out what we call the vector. And of course, this is not string to you. You remember when we started, we talked about row and column matrices. And I remember you answered some question on that then, where you have the number of rows, the number of columns, number of rows by the number of columns. And I've told you that most of the work we do in machine learning, they are represented as matrices. You can have them very few, like 2 by 3 or 2 by 2, and you can have them as much as millions. I've told you that I've used Dataset before in millions. So you can have them as, and when you have such number, you see you have multi-dimensional. That means the dimension is so large, millions of rows, maybe thousands of columns. So we want to convert this document to such vector. So how do we do it? Very simple code. I'm going to run for you now. So I'm going to take another cell to be able to run this. So what I'm going to run is I'm typing print. So I will call a function that has been already developed inside of this package we're using, and I say back to array. So when you call on back to array function, what it will do is that it will convert your bag. You remember bag? So I want to change this bag to array. So let me run it and you see what I'm actually talking about. So let's run it now. Can you see? This is what we want to achieve. We have converted this stuff here, this text here. Now we've converted them to numbers. If you notice, you will notice that here we have how many lines? 1, 2, 3, 4. That's 4 rows. And if you look at our array, also is 4. 1, 2, 3, 4. So we have 4 arrays based on the bag of words we have created. So how did we get this? We only called to array function. We call it on bag by using dot operator. Dot operator means attach to array with bag. So Python will go and check your bag. Your bag is this, which is CountVectorizer docs. And now convert it to array. And that is what we have done here. Any questions so far? Any question?
No.
Is it making sense to you? Is it making sense to you? Or you want me to go through anything? What did he say?
Fast. The explanation is a bit fast.
The
explanation.
Okay, it's a bit what?
Fast.
Fast. Oh, fast.
Yeah.
Did you mean fast?
Yeah.
Oh, okay. Please, anytime you think explanation is fast. You might just call my attention on time. Okay?
Okay.
Yeah. So let me repeat the explanation then. So where would you want me to start the explanation from?
From the count vocabulary explanation.
Okay, cool. So I'll do more than that. I'll go back. For this work we want to do, I said it earlier on that what we're attempting to do is to change text to numbers, because that is what our computer will understand for the model we want to build. We said we're using sentiment analysis or emotional analysis. When somebody has watched a movie, how do we know the emotion of this guy or the sentiment this person shares after watching that movie? Is it a positive one or a negative one? Or I have a customer that is patronizing my online business, or I have a collection of customers. I need to know how they feel when they buy a particular product to help me build on my strengths or correct things that they have noticed. So I need to be able to have a model that will do that job for me. But it turns out that computers don't understand text. But the people who express their feelings, for instance, when you read the post of your friend on Facebook and you want to make a comment, will you type 01000002? Is that what you type?
No.
You say, oh, this picture is beautiful. Is that correct?
Yeah.
Yeah, that's your emotion, that's your expression. But computer do not understand this picture is beautiful. And I want to make sense. Facebook, for instance, needs to make sense from the review people are making or the comment they're making. So as to build analytics or analysis for people. So they will, okay, for people, they like this kind of product from me, they like this kind of picture from me. So there is need to have such model that will be able to convert words to numbers. That is our job now. We want to convert words of expressions, word of emotions that people have expressed, convert them to numbers that computers can relate with. You understand when you hear this picture is beautiful, but computer do not understand this picture is beautiful, but it does understand 01001111100011. Computer understand that. In fact, that's how it stored information. But you understand this picture is beautiful, and you want to use computer, so you must dance to the tune of computer. How do you dance to it? You must look for a way of converting this picture is beautiful to 0100110001 or whatever arrangement. So that is our attempt here. Now, to have a kind of view on what we're actually doing, we just chose to create some expressions. So the sun is shining. You could change it to, this picture is beautiful. Maybe I should even do that. So give me some expression. This picture is beautiful. What other expression do you think people make on the internet, on Facebook comments, or any other social media comments? Can you give me some comments?
That people what?
Okay, for instance, if you go to the internet, if you go to the Facebook, your Facebook account, and your friend has posted pictures, what do you think? What are the likely things people will say about the picture?
That's a nice picture.
What a nice picture! Thank you. What a nice picture. Cool. That's correct. Give me another one. Let me change this one away. What do you think someone else will say? And that guy will put, someone that say, what a nice picture. You see the guy will put some exclamation mark, right? What a nice picture. What other thing?
Yeah.
What other thing do you think people will say?
People can say, you look really young here.
Okay, you look really young here. So maybe you were old before, but in this one, oh, you look really young.
Maybe
Okay. Okay, cool. What other thing do you think people will say? Just give me one more word. Someone that does not like, if let's say assume somebody's fighting with that person who posted a picture, and the person wants to bring it to the social media. What do you think such a person will write here?
person can
Waiting.
write. The person can write. I don't like this your clothes. Something like that.
I don't like this. Your post. Your post or your post, whichever one.
Your
Post is
clothes,
correct.
clothes.
Your clothes, okay.
Post
Post is also correct. Your
or
clothes.
post. Yeah.
Yeah. Okay, I don't like this, your clothes.
Anyhow.
Okay, cool. So we have got expression. This is what we're trying to do. So how will we change this to a format, to a form which computer we understand? How do we do it? So that's what we did with np.array. So np.array, we make an array of numbers with this. But you cannot just do it like that. It has need of some other tools before it can change this text of expressions to words, to numbers, sorry, to array, to number array. Okay, people have done a great job. They have created a tool called TfidfTransform. With TfidfTransform, you can actually change this and transform it. So how do we transform? All you just need to do is the count you have created, the CountVectorizer, which we imported from sklearn. Sklearn also has TfidfTransform function. So you call this TfidfTransform function on the object count, and you pass in what you'll be telling it to be telling you, what do you want me to transform now? And you say, please transform for me docs. Transform it for me. And when it does do the transformation, you will have it would have created some bag of words. Let me silence this first. So let me run this again. So you can see here the transformation has happened here. But what I want to show now, I want to see what is actually happening under that is not open to the world. So for me to know what is happening under the word, I want to show forth in the word is print. Print means show it to the world. Let me see what's happening. And what do we print out? There is a method. There is a vocabulary attribute that we can actually call on count, which is this CountVectorizer that has been instantiated on count. By saying count.vocabulary underscore, it will show to you the transformation that has happened under the hood. So you see now that our word has changed. This is now 10, picture is 8. So this indexing is done alphabetically. You can see now that our words have increased to what's the longest one here? Y 13, 14. So now we have 14 words, unique words. Unique is important. Unique. We have more than 14 words, but we have 14 unique words, meaning that this might appear 10 times or 5 times or 2 times. But the unique word is this. Picture might appear 200 times, but the unique word is picture. Is might appear 1,000 times, but the unique word is. So here is the unique words that will be printed out, and we have them. So that means document has been converted from what it used to be, from text to numbers. But not only number now, there is also a mapping to what each word is. So with this now, computer is good to work because it has a key and it has a value. So it actually needs a value. All you just need to do is to index that particular value and it will know what word it is. Okay. So we are even now saying that even much more, we can still do something more with this information. That is, we want to see it in vector form. When we say vector, don't be big, don't be worried with the big word. It just means rows and columns. How many rows of numbers do we have and how many columns do we have? So here now we use to array function to convert the bag attribute to a vector. And that's what this does. So you notice here that we still have the same four rows, but the column now are changed because we are using different words. So see what column changed to. How many columns do we have now? One. Can you count with me the number of columns? One to go. One, two,
three,
four,
five,
six,
seven,
8, 9, 10, 11, 12, 13, 14, 15. So we have 4 by 15 matrices. So our vector now is 4 by 15 vector. 4 by 15. So we call this vector a sparse vector. Why do we call it sparse? Because of the number. We have a lot of zeros in this arrangement. So we call it a sparse vector. Does that make sense up to this point? Do you now understand, Tochi?
Yeah.
Okay, please, anytime you think I'm fast, let me know so I can slow down as much as you want. So you'll notice here that each index position in this feature vectors, so we call this feature vectors. So each index position corresponds to the values, to the number that are stored as dictionary items in the CountVectorizer vocabulary. So for instance, if you look at this, the first feature at index position 0. So what's the index position 0? Look at index position 0. That is beautiful. Is the index position 0. Is that correct?
Yes.
So let's see. Index position 0. Where does it appear? Beautiful. Appears here. So you see that the feature of the first feature at the index position will resemble the word that is associated with that. And it takes the unique value. But as you also look at this, you will realize that some words appear frequently. But unfortunately, we have created our words that not to appear frequently, like this picture is beautiful. Okay, is appears once, beautiful appear once, picture. So everything we use here, I think, okay, picture, okay, for picture appears 2 times, 2 times. Cool. So now that I've seen that, I need to now, because of what I want to explain next, I need to go back to the original word we used, which is going to be what I'm going to create now to explain. Or no, let me just leave that. Let me leave that so as not to mix things up. The next now will be that you will notice, okay, let me go back to this document. So now switch back to me now. I've left the collab. I'm presenting the document now. So look at this example we have here. The sun is shining, the weather is sweet. You see, the sun is shining has been converted to this list. The weather is sweet has been converted So we have now something that computer can understand. But you realize something, that there are some words that appear frequently. They are very common in English language. Like the man is good. The. Then we have some words that are also common. Tochi, can you give me an example of such words that are very common in English? They appear frequently.
Hello.
Hello, I can hear you.
How are you?
How are you? Okay, those are words. Okay, but single words like, so hello is common too. You are right.
Me,
What do you say?
me, you,
Okay,
us.
okay. Thank you. Such words are common. They are more common. They are much more common than some other words. Then some super common words are. Look at the screen now. There is super common. Is super common. A super common. Now think about it. Imagine that you are reviewing. You want to review. You want to know the emotion of someone about a particular product he has bought or she has bought, or about a movie he has watched or she has watched. There are some words that will not help you know how that person is feeling. A, is, they will not help me to know. But there are some words that will help me know how that person is feeling, like love, like, hate, good, bien, muy bien, for instance, in Spanish. So those words will make you know that, oh, this person actually love this movie, love these tacos, or does not love these tacos. When you hear mal, then you know something's wrong. When you hear muy, bien, bien, buena, all those things, you know, this guy loves this thing he has eaten or he has watched. So those words that help us know and help us make judgments about the person's emotion. We need to keep such words. We need to look for them and look for a way to teach our computer to know such words. So I want to introduce you to something now, which you just have to understand it and try to go along it. So the first thing I'm going to talk about is the TF. Can you see that? Can you read it? Read this line and this box, TF-IDF, the smart counter. Can you read this, please, Tochi?
TF-IDF, the smart counter. TF
Okay.
equals term frequency, how often a word appears. IDF equals inverse document frequency, how rare / special the word is.
Okay. Keep reading the magic formula.
Magic formula. The magic formula. Common words are small scores. Rare special words are big scores.
Okay.
Example,
Example.
amazing is helpful than the.
Cool. You see what we're talking about here now, the TF and also IDF. These two terms are very important. TF means the time frequency. That means how frequently does the word appear. So if you take an English text, you will see they appearing many times. A appearing many times. Is appearing many times. So those words appear often. But amazing might not appear frequently. Extraordinary might not appear frequently. So such words that don't appear frequently, we call them words under IDF, inverse document frequency. The words that appear frequently are termed term frequency. Now look at this example. Read this TF IDF explained with pizza. Can you read this one? Read this slide.
Which one? Which one?
Here, I highlighted it.
Imagine rating pizza reviews. Word the appears in 100 out of 100 reviews. Score very low. Not helpful.
Okay, hold on there. Hold on there. Now, here, the word here is the, and it appears 100 out of 100 reviews. That means this word is too common. It's too common. So this formula will penalize the word. The TF, this TF will penalize the word, because you see the magic formula here says common words, they get small scores. So word like they in the review of this pizza sale will be penalized because it has appeared. It's so common. This guy is so common. It's reachable. And that means it's common. Now, let me ask you a question. Do you see the president of your country often? Do you see the president of a country often live? You talk to him often?
No.
Okay. Do you see your teacher often? Your teacher,
Yeah.
do you talk to it? Good. So look at it that way. The president that you don't see often, it means she's not common to you. She's not common to you. She's far from you. So in this magic formula, such a person, let's assume she's a word, should be given big scores because it's a rare special word. You don't see her often. Then your teacher that you see often, in the case you are considering, you will associate with it small scores. Okay, so that's a point we're raising here. Continue. So start again and continue the TFIDF explained with Pizza.
Okay. But was
Continue.
Okay.
I said you can start the slide again. Read the slide again.
Everything?
Yes, yes.
Imagine rating the pizza reviews. Imagine rating pizza reviews. The word B appears in 100 out of 100 reviews. Score very low, not helpful. Word delicious appears in only 10 out of 100 reviews. Score high. This is special. The word disgusting appears 1 in 5 out of 100 reviews. Score very high. This is rare and important.
Do you understand now the time that TF-IDF? Do you understand that now?
Yes.
Okay. So it means those words that are that appear commonly, they are under TF, time frequency. Then the IDF is an inverse document frequency. The words that don't appear frequently, you give them high score, and that will help to do the proper review. Okay, so far, so good. The next level we will go to now. So after dealing with this one, I will allow, I believe you are typing the code, right?
Yes.
Okay. So the next thing is this. Remember that when
Scroll
you
up.
write review,
Can you scroll up a little? I had not finished writing all the code. That one I did. It's the second one I haven't done yet.
you're done with this first cell, right?
Yeah.
Are you done?
No.
Okay.
Error. I got an error.
What's the error? Fix it.
Bag.
Is it?
There.
I didn't hear what you said.
Yeah, done.
You're done. Cool. Before we go to the next point, I was saying that you come up with unclean words. Like what I mean by unclean now is I don't mean bad words. I talked about HTML, that's hypertext markup language, which is used for writing the website, the language that is used for designing websites in the HTML language, although there are other languages. But for this case now, we were looking at this particular reviews we are talking about. Especially the data sets we are using, that Imdb data set, it has some words that are, okay, let me use this example. This should be, I don't know if it's applicable. Have you seen mommy cooking beans before? Tochi?
Yeah.
Do you know the process?
Yes, I have.
Have you seen her picking some stuff away from the beans before she cooks it? What are some of the things she picks out from?
Stone.
What are some of, what is it?
Stone and some dirty.
Cool. Yeah, good. So that's what I want. Now you'll be wondering, why do we have stones in the beans? Because one of the reasons would be beans was planted on the ground. It germinated on the ground, it grew and was harvested. So the responsibility of some mixed up with the sand, the small stones that are mixed up with the beans that in the process of processing or whatever way. Somehow, it turned out that stones ended up in our beans. Now, will you say I need to eat all the beans with everything that is in it? No. That was why mommy we picked out some of those stones. The same thing I'm trying to explain here now. When somebody make a review, for instance, you make a review here, you look really nice. This picture is beautiful. You will see the person will put some emoji. An emoji sign will be put there. The person can put eyes and put some stuff, or just put things just to show that it's expressing stuff. So for you to have proper review, you need to take out those messy things, take them away, as mommy will take out the stones from the beans. Because if you don't take them away, as you are eating your beans, those stones that ended up in the pot might do damage to your teeth. And that would not be a nice thing. So if we don't take out these HTML related characters from the data set and they end up in our model, they will do damage to the performance of our model. Our model will not be reliable, and we don't want such a thing. So it's important we do some cleaning up. But before then, I talked about the I just talked about the TF-IDF. So let me do some code for what we are talking about, for you to see what we are actually expressing. Now, you take note of your words or the array. Look at our array before we do the TF-IDF. TF-IDF helps us to deal with words that appear frequently. And then we're left with words that don't often appear frequently. And so we now have we balance such that the words that don't appear frequently are rated high, And those that appear frequently, they are rated low. So this will be the code you are going to use for that. Just go ahead again and write with me. sklearn, it's still sklearn we're using. From sklearn dot, it's still feature extraction, then dot text. Now we'll be importing this TfidF transformer. It's already implemented in scikit-learn. TfidF, and you know, I have talked about it. TF means term frequency. IDF means inverse document frequency. Now, if you can see my screen properly, there are some things popping up telling us more about TF-IDF transformer. You see, it transforms a count matrix to a normalized TF or TF-IDF. Where are you? So TF means time frequency, while TF-IDF means time frequency, document frequency, sorry. Okay, I want it to show properly for you to see. Okay, cool. So transform, that's TF-IDF transformer. What does it do? It transforms a count matrix. What we just did now, this is a back to array we did, and we got this vector. It transforms it to a normalized. Normalized means between some values to values. Sometimes you might have words that span 0 to 2 or more than that, but you want to normalize it that we don't want to have higher values because of imbalance of frequencies. So TF-IDF transformer transform a count matrix to a normalized term frequency or term frequency inverse document frequency representation. Now TF means term frequency, while TF-IDF means term frequency times inverse document frequency. This is a common time weighting scheme in information retrieval that has also found good use in document classification. Now, can you read with me the goal? Read with me now. 1 to go. The goal. Can you see my highlight? Okay, yeah. Good. The goal of using TF-IDF instead of the raw frequencies of occurrence of a token in a given document is to scale down the impact of tokens that occur very frequently in a given corpus and that are hence empirically less informative than features that occur in a small fraction of the training corpus. In a nutshell, it's telling you that you have high number for president that you don't see frequently, and you have low number for your teacher you see frequently. That's the meaning of all this grammar. Token here means words. Token means word. Given document means this document we just created. This is a document already. This is a document. This is a document. This is a document. This is a document. So when you have them together, you have what you call corpus. So I'm trying to break down what they have here. Where are you? Okay. Now it says to scale down the impact of tokens that occur very frequently. That means those numbers that occur very frequently, you want to scale down their impact. You want to reduce their impact. And also, because they don't give you more information about the work you are doing. Okay, I think that's fine. That's fine. I may just copy this for you. But let me do something. Okay. This is just additional information, but I've already explained everything on this matter. Okay, let's continue now. So we are importing this sklearn from sklearn.feature extraction.text, the submodule.text submodule from the module feature extraction in the library sklearn. We're importing text frequency, inverse, document frequency, transformer. And the job is what has been explained here. Now let's create an object, TfIDF. You can call it anything, up to you. So for this, because we want to normalize, so you use TfIDF, which we have imported, transformer, and you call on that function. So this function takes some argument. So, and the argument is shown here. It takes normalization. Now, normalization is at statistical walls. We have different type of normalizers, but I'm not going to dwell on that. But we use what we call L2 normalizers most times, many times. L2 normalizers. Can use L1. There's also L1. There are some others, but take this one. We just use L2 is common. Then there's another argument it takes, which is use IDF. It takes a Boolean true, smooth IDF. That's another argument. Boolean true. Then there is a sublinear time frequency. It takes a Boolean false, and this will pass into TfIDF transformer. Okay. So let's go on. So this is the mathematics behind this. So you can even read this on your own. So this is the mathematics behind this function we are calling. Now I'm not going to go on that. So all I'm going to do now is just to use what we have seen. Let's pass in the argument. So we're going to pass in argument TfIDF, and we pass in the Boolean true. Okay. Then I'm going to pass in another argument, normalization. I normalize it with L2. Then I pass in another argument, smooth, how smooth the IDF, smooth function for the IDF. So I pass in the argument true, smooth IDF. Okay. So this will be the argument we're passing to this transformer. The next thing is, we'll say numpy.set print options. So that's okay. Let me. Okay, maybe I should. No, okay. I will write it, but I will not use it initially. I want to show you something. Print options, and I say precision. I'm going to set precision to 2, but I'm not going to use it yet. So let me comment it out, and you will see the need to use it. Now, after we have written those 2 lines of code, then the next thing is to print. So I want to print TfIDF, this one that I've set here. So I said print TfIDF, then dot fit_transform. And then that is the function I'm calling. This function, I need to pass into it count.fit_transform. I'm going to explain something, but let me just finish with the code. Docs, you remember we created docs up here. Okay. And after that, I will change everything to array. So I'll call to array function on it. So let's run it, and I will explain each one. Okay. So let's run this. Okay. Can you see what you have printed out? So here, this guy here is the same thing. This bag we have printed out here, back to array. It's the same thing we're printing here now, but with a transformation using TfidfTransformer. But take note of something. I want to change something here. I told you I'm not going to comment out this. See the state our arrays are now, and I'm going to take out this. I will run the code, and you see for yourself why do, what is that? Set print mp.set underscore, sorry, mp.set underscore print options. Cool. Now, can you see the difference? What is the difference between this and let me repeat this code. This code here. So what is the difference? Okay, here, see, okay, I understand. Because for me to get what I want to actually show, I need to interrupt execution, clear output, and restart session and run all. Restart session and run all. So I want to show, you already seen it, but I just want to make it explicit. I'm sorry. Yeah, let me take out this.
All right.
Take out. What is it? Are you talking to me?
No.
Okay. So I've taken something out here. Oh, sorry, run all outputs. Restart session. Okay, it's here. It's here. Okay. Okay. Oh. Okay, this is what I wanted to show. So one thing you'll notice here is, can you see how long this one is? Like 1, 2, 3, 4, 5, 6, 7, 8. So the output here is such an output because we didn't set the precision. So by setting the precision to 2, that means we are saying take it to 2 decimal places. So that's the essence of calling this one, okay? So I can take this one out conveniently. I can take this out, doesn't matter. Okay, cool. So with set precision, set printout options precision to 2, with that, your precision or your output will be in 2 decimal places. Let's say you make it 1. So you see now, or if you make it 3, the same thing. So it's just changing the occurrence, the decimal places. So let me use 1 here. So, and now by comparing this output with this output, you will notice that this output is in the range of 1 to 0, 0, 1, 0, 1, 0, 1. But now it has been normalized to a value that are close by. So this is even so, assuming we have, this is so because the numbers we have here, or the document here, or our corpus here, which is combination or collection of document, is such because we don't have many words that are reoccurring as such, apart from picture that appears twice. I think others just appear one time each. So, but the idea here is the TfIDF transformer. We use it for normalization. Please, that's very important. We use for normalization to ensure that words that appear frequently are scaled down, they are penalized, because we don't derive much meaning. We don't derive tangible meaning. The meaning or the information we derive from them, from such words, are very marginal. So they're not actually as important as words that don't appear frequently, that has big implications. So we use TF-IDF transformer for that purpose, for a normalization purpose. Is that okay? Is that okay?
It's okay.
Tochi, are you there?
Yeah, it's okay.
Okay, cool. So I'm going to stop here. You're going to write the code. Now, please, you take this. What I'm going to do for me is write minimum of 50 right, minimum of 50 inch on 1 sentiment analysis, 2 bag words, 3 TF, 4 idea, 5 write short notes. TF-IDF transformer, TfIDF.FitTransform, and CountVectorizer. Okay. Sentiment. This is sentiment. Sentiment. So is that okay? So this would be what you're going to work on. We're going to have another session tomorrow. I will expect it tomorrow. Okay. But you can still run the code and see any lessons to still learn from it. I'm going to end here today. In case you have any question, kindly let me know. Otherwise,
Gracias.
What do you say, sir?
I say muchas gracias.
Okay.
De nada. Ibamaki.